Chapter 9 Climate Regions and Climate Change. Section 9.2 Climate Classification. So let's now look at the topic of classifying the Earth's climates. And we're talking about the climates that occur at various locations. We just learned that there are many different factors that act to create the variety of climates that we find at locations on our planet. Yet some locations have similar factors operating and therefore have similar climates. And a good example of that is California and Italy. Both of those locations have what's known as a Mediterranean type climate. So one way to treat climate classification is by temperature. The ancient Greeks had a climate classification system that suggested there was three types of climates on the known Earth at that time. There were frigid climates that occurred roughly above 45 degrees north latitude, between 45 and 30 temperate climates, and from the equator to 30 degrees warm or torrid climates. We're going to use this basic idea in studying climate classification. We're going to look at something called the Köppen climate classification system, and it uses a system where 5 letters are used to represent the various types of climates, with A being tropical climates that are located along the equator, B being subtropical climates found in the part of our planet that's influenced by the subtropical high pressure system. We have 2 types of mid-latitude climates, ones with mild winters, which are given the designation C, and then another set of mid-latitude climates that have severe winters or colder winters, which are represented by the letter D. The final type of climates are polar climates in this classification system, and they're given the letter E. So the Köppen climate classification system is the most widely used system for classifying the world's climates. It was created almost 100 years ago by Vladimir Köppen in 1918, and it categorizes a location's climate based on looking at annual and monthly averages of temperature and precipitation data. As I said, this climate system recognizes 5 basic climate types plus 1 extra, which we'll call a highland climate. So the basic characteristics for these 6 major climate types are the A, or tropical moist climates, are found near the equator, and in these climates all months have average temperatures above 18 degrees Celsius. We then have the subtropical climates that are given the letter B. They're called dry climates. Their precipitation doesn't match the amount of moisture that's lost due to evaporation and transpiration. And because of this, they have desert-like conditions, specialized vegetation that has the ability to store water because water is deficient. The sea climates are these climates in the middle latitudes that I talked about that have mild winters, moist mid-latitude climates with mild winters. Coldest month is somewhere between 18 degrees Celsius and -3 degrees Celsius in these climates. Then we have moist mid-latitude climates with cold winters. Here the warmest month is greater than 10 degrees Celsius, and the coldest month is colder than -3 degrees Celsius. The final climate that is classified latitudinally are the E climates, which are found in the polar regions, so roughly above 60 degrees north or south towards the poles. These have very cold winters and cold summers. The final climate that is in this classification system is one that is defined by altitude. So elevation is creating these climates, and we'll call these the H or highland climates. So they have cooler temperatures because they are not near sea level. The following map shows the global distribution of these 5 latitudinally defined climate types, the A, the B, the C, the D's, and the E's. Highland climates aren't identified on here. Also notice that there's one little tweak. They identify an AS climate. I'm not going to talk about an AS climate in the classification that follows. So let's focus on at first the tropical moist climates, the A climates. So these extend from the equator to about 15 to 25 degrees of latitude. In these climates, all months have an average temperature greater than 18 degrees Celsius. There's also very high amounts of precipitation occurring in these climates. So precipitation is generally higher than 1,500 millimeters per year. There are 3 minor Köppen climate types in the A group, and these minor types are defined by the seasonal distribution of rainfall. If rainfall occurs evenly all year long, the climate is called an AF, or tropical wet. And these tropical wet climates tend to occur very, very close to the equator. If the precipitation is greater than AF and falls in at least 7 to 9 of the hottest months, it can be designated an AM, or tropical monsoon climate. And then the final type is a tropical climate with a distinct winter dry season and, of course, summer wet. This climate is called tropical wet and dry, or savanna, and given the designation AW. So here we see the location of the AF climates. As I said, they're very close to the equator. They're on the equator. Even precipitation. And here's an example from Suriname. Latitude 6 degrees north, elevation 2 meters. So that precipitation is pretty even throughout the year. It's getting at least 100 millimeters per month, maximum almost 400 during June. Notice how consistent the temperatures are. So those are the red dots and green line. Temperature doesn't change much from month to month, averaging about 26, 27 degrees Celsius every month. And that's average monthly mean temperature. Here's another example. Iquitos, Peru, at 4 degrees south. Once again, take a note of the temperature. Not much change here, averaging somewhere between 26 and 28 degrees Celsius, mean monthly temperature every month. And once again, the precipitation is fairly consistent from month to month. Now, both of those tropical climates originally were dominated by tropical vegetation, very diverse types of trees, many types of trees, trees that grow at least 20 meters above the surface of the ground, sometimes as high as 40 meters, and very thick foliage, very little light passing through to the ground. So here we see an example of true tropical rainforest. And of course, true tropical rainforest never loses its leaves. It's an evergreen form of trees that live in this type of climate. So our AW climates are climates that occur outside the true thermal equator that was shown in the AF. They have a seasonal wet season during the summer, and a dry season during the winter. During the dry season, the intertropical convergence zone moves out and is replaced by the subtropical high, creating drier conditions. Calcutta, India, would be an example of an AW climate. Notice that all the temperatures, the monthly temperatures, mean monthly temperatures above 18 degrees Celsius. They peak in May and in September. Precipitation occurs during the high sun season, the summer. It's in the northern hemisphere, and the precipitation is a lot greater during the summer season than it is during the winter season. Cuba, Brazil, is another example of an AW wet and dry climate, tropical climate. But this one is at 14 degrees south, so it's in the southern hemisphere. So the seasons are reversed. May, June, July, August is the winter season, low sun season. High sun season is November, December, January, February, and March, when it gets more precipitation. During the summer season, the intertropical convergence zone moves in, provides precipitation generated from thunderstorms. During the dry season, that's being caused by the intertropical convergence zone leaving and being replaced by the subtropical high pressure zone. Now, AW climates usually have a mixture of grassland and forest. The ones with more precipitation have more forest, less grassland. The ones with less precipitation have more grassland and less forest. So they vary in terms of how much forest cover and how much grassland cover occurs. Monsoon climates, the AM, tropical moist, occur in certain regions of the world where precipitation is enhanced, usually because of orographic uplift, and they get a lot more precipitation than AW or AF type climates. And the first example we'll look at is from Bangladesh. Chittagong is an AM climate at 22 degrees north. Notice the temperatures are all above, monthly mean temperatures are all above 18 degrees Celsius. And it gets a lot of precipitation in June, July, and August. So the total looks approximately over 2,000 millimeters of precipitation just in those 3 months. So that compares to about 300 millimeters or 30 centimeters for Kelowna, where I am. Here's another example of a AM monsoon type climate at 10 degrees north in Cochin, India. Once again, notice the temperatures are pretty consistent, very, very warm, and heavy levels of precipitation that begin in May and don't end till about October. That is a monsoon type climate. And our next category is the dry subtropical climates, our B climates. So dry climates B, as I said before, the most obvious feature of these climates is precipitation does not meet the needs required by the higher temperatures for evaporation and transpiration. These climates generally extend from 20 to 35 degrees north and south of the equator. And they're also tend to be located at higher latitudes in the center of continental regions that usually have mountains that remove moisture, mountains that are downwind. And for example, much of southern interior BC is a B-type climate, and that's because the precipitation has been removed from orographic uplift as it went over the mountain ranges to the west. There are two minor types in this climate, in the B category, and those minor climates are BW, dry arid, or desert. So these are true desert climates cover about 12% of the Earth's land surface. Very, very dry. They may have no vegetation at all, or scattered xerophytic vegetation like cactuses and thick waxy-leaved shrubs. And then we get another B category with a little more precipitation, and it's a grassland type climate, and it covers about 14% of the Earth's land surface. Of course, the BS receives more precipitation, and that precipitation can either come from the intertropical convergence zone or the mid-latitude cyclones, and that depends on its geography, whether or not it's influenced by either one of those two. These two subclimates, B climates, BW and BS, can also be further defined as being either subtropical, H, or do they occur in the mid-latitudes and are the result of enhanced drying due to the presence of a mountain range to the west. Here's the locations of the BW climates, so you can see they're quite extensive, with the darker red being the subtropical BWH, and then the the mid-latitude BW climates are the BWK, and they're that lighter shade of red. So Luxor, Egypt, at 26 degrees south is a good example of BWH type climate. As you can see, almost no precipitation at all at this location. Temperatures peak during the high sun season and are somewhat lower during the winter season. Still, pretty long days here during winter, and the sun is still relatively high above the horizon. For December 30 or 21st, we would expect it to be roughly about 40 degrees above the horizon. So that's equivalent to the sun here in Kelowna during equinox. Another example of a BWH is Alice Springs, Australia, at 24 degrees south. A little bit more precipitation here, and similar pattern in terms of temperature, although this location is in the southern hemisphere, so winter and summer are reversed. Subtropical dry climates, like the BW climates, generally have vegetation that is highly adapted to drought conditions, lack of precipitation, like in this picture here where we see cactus vegetation and a variety of different types of shrubs. Many of these shrubs would have very, very deep roots, so they can tap into groundwater that is some distance away from the surface. Some BW climates exist in the mid-latitudes. An example is Lovelock, Nevada, at 40 degrees north. So it's designated a BWK, not an H. K indicating that it is one of these continental climates, and being in Nevada, it's on the leeward side of the mountains along the west coast, which enhances the dryness that occurs here. Temperatures are a little bit cooler because it's at a higher latitude, so winter temperatures get close to 0 for the mean monthly temperature. Summer temperatures still get pretty high, in the 20s, low 20s for the summer months. And precipitation is low, with just small amounts occurring almost every month. BS climates are a little wetter. They're sort of a transition climate into true tropical savanna that we described our AW. So these are a little bit drier, more grassland, very few trees. There's two types. There's the ones that occur in the subtropics, the BSH, and then we'll see there's a number of BSKs, which are in the mid-latitudes. So a BSH would be this transition from AW with grasslands and trees, savanna, into the drier sort of BSH, H indicating that it's in the subtropics. So these climates don't, the AWs don't transition into the BSKs because those are in the mid latitudes. That's not what occurs. But you can see in this BSH, Monterrey, Mexico, 26 degrees north. Minimum temperature is about 15 degrees during December and January. Maximum temperatures almost into the 30s, high 20s are the summer temperatures at this location. Quite a bit more precipitation than what we saw with the BWHs, but still evaporation and transpiration exceeds the amount of input from precipitation. Bulawayo in Zimbabwe is another BSH, so at the subtropics, 20 degrees south, but it has the opposite season. So wet season here is when it would be influenced by the intertropical convergence zone. So December, January, February would be the high sun season. Low sun season would be June, July, and August. That's when it's dry. Subtropical high pressure system dominates during this time and causes the lack of precipitation. An example of a BS mid-latitude climate is Denver, Colorado. So you can see here the temperatures are cooler because it's at a higher latitude. Still gets more precipitation than a comparable BWK, and precipitation here. Winter would probably be mid-latitude cyclones, while summer thunderstorms. Let's now look at the mid-latitude climates. And the first is the moist subtropical mid-latitude climate C. So these generally have warm and humid summers with mild winters. They're found anywhere from 30 degrees to 50 degrees of latitude, north and south, and mainly on the eastern and western borders of continents. In the center of the continents, it gets dry, and the climates are more of a S type, or a BK with the mid-latitude designation. During the winter, the main weather feature that occurs here is the mid-latitude cyclone, bringing precipitation into these areas, whether they're on the west coast or on the east coast. Summer is dominated by convective thunderstorms, so warm temperatures in southeastern United States, where there's a lot of these climates, these moist subtropical mid-latitude climates. The moisture source is the Gulf of Mexico, and that air moves in and produces many thunderstorms. So here we see the where these C-type climates occur, and we'll identify three types: CF, CW, and CS, with CS being a Mediterranean-type climate. And those Mediterranean climates, the CS, we can see them here in California, in Spain, Greece, Italy. The CF climates, examples of the CF include southeastern United States, much of Western Europe, and parts of India and China. And then we have the more rare CW type climates that are a little bit harder to identify where they exist on this map. So the CF is mid-latitude wet climate. CF has precipitation all year long. Summers can have frequent thunderstorm activity. Winter precipitation comes from mid-latitude cyclones. And a good example is the home of Coca-Cola, Atlanta, Georgia, 34 degrees north, is a CFA. So the temperatures are quite mild. Mean monthly temperature in January is above zero. and a lot of precipitation. So we can see many months are over 100 millimeters or 10 centimeters. In the southern hemisphere, Buenos Aires, Argentina, is an example of a CFA. Notice here the seasons are reversed, so the coldest months are in June, July, August, warmest months in December, January, February. Precipitation, once again, is relatively high. If you went there, you'd see the vegetation is probably deciduous and growing well, deciduous trees. Another example of a CF climate is Vancouver, Canada. So at 49 degrees north, although most of its precipitation is in the winter, thunderstorm activity is actually quite rare. Mid-latitude cyclone provides a lot of the precipitation for Vancouver monthly. Temperatures, once again, above zero for a mean monthly temperature. And its summers are a little bit cooler because of its proximity to the ocean. Cools it off. London, England is a CFB. So once again, considerable precipitation, temperatures above zero, but and for low temperatures, and a little bit below 20 for the high temperatures in the summer. In the interior of the continents, we get CW mid-latitude winter dry climates. They generally have a humid summer with a short dry winter. Most of the precipitation occurs during the summer because of the presence of mid-latitude cyclones and or thunderstorms. Here are some examples of some CW climates. Omaha, Nebraska, 45 degrees north in the center of North America. As you can see, the temperature variation is quite large, from about 25 degrees in July to -5 in December and January. Precipitation is mainly in the summer months, and as described with the CW classification, the winters are dry. I don't even want to try to pronounce this location in China at 23 degrees north. I don't want to butcher it. It's a CW climate, once again, high amount of precipitation during the summer months, dry winter. Because it's closer to the equator, it doesn't get as cold in the winter months as Omaha, Nebraska. It looks like minimum temperatures are about 15, high temperatures about 26, 27 in July and August. Along the west coast of continents, we get Mediterranean climates, and their letter designation is CS. They receive their precipitation primarily in the winter season from the mid-latitude cyclone. In North America, they extend from Oregon all the way down into California. The extreme dryness of the summer is caused by the presence of subtropical highs that can last for up to 5 months. Here's an example. Rome, Italy is a CSA climate at 40 degrees north. Temperature variation is not that great, so it's a mild climate, not that variable. Dry summers, wet winters, and I said the winters are from mid-latitude cyclones. Temperatures about 24 in the summer, down to about 9 in the winter. Santiago, Chile is a CS climate. Now, the seasons are reversed here, so the wet season truly is winter in May, June, July, and August in the southern hemisphere. Dry summer months when the subtropical high pressure system moves in and dries things out. Temperature variation from roughly about 8 to 20 degrees Celsius for mean monthly temperatures. That'd be a nice climate. North or poleward of the C climates are the D climates. So these are mid-latitude climates that have similar characteristics to the C climates, except that they're colder. So they tend to have warm to cool summers, cold winters. We have many of these climates in Canada, D climates. Winnipeg is a D. Regina would be a D. So the more poleward of the C climates. Average temperature of the warmest month is greater than 10 degrees Celsius, while the coldest month is less than -3 degrees Celsius. And living in Winnipeg, I can tell you it's way colder than -3. Way colder. Winters can have severe thunderstorms or snowstorms, strong winds from the interaction between subtropical air and cold polar or Arctic air masses. Like the C climates, there are 3 minor climates, and 2 of them are DW and DF. So here is the location. There's also a DS that we won't talk about. Here's the location of these moist continental mid-latitude climates, these D climates with the cold winters. So you can see much of Canada is a D climate. Even Toronto is a D climate. Much of Eastern Europe and Siberia, Russia are D climates. So there's my hometown, Winnipeg. So take a look at that January temperature. Looks like about an average of about -18 degrees Celsius for a mean monthly mean. But summers do get warm, they do get pleasant, so topping out at about 20 degrees mean monthly temperature. Precipitation, summer is a lot of thunderstorms. Mid-latitude cyclones are responsible for the precipitation in the fall, winter, and the spring months. Here's another D climate in Canada, but it's a DW, so it's got a dry winter. Calgary, about the same latitude as Winnipeg. So we can see more summer precipitation from things like thunderstorms. Temperatures not as cold as Winnipeg, but still pretty bitter. High looks like about -18 for July, and it gets down to about -10 in January, its coldest month. Polar climates, so our E climates, so these are nasty climates in terms of temperature. Warmest month is less than 10 degrees Celsius. These are found in the northern coastal areas of North America, Europe, Asia, along the land masses of Greenland and Antarctica. 2 minor types of this climate exist. An ET, which is polar tundra, so it's not permanently covered with snow and ice all year long. It does, the vegetation does appear during the summer months. If you dug in the soil here, you'd find permafrost. Vegetation is dominated by mosses, lichens, dwarf trees, and scattered shrubs. Trees can't grow very high because the winds are just too cold in the winter and would kill the trees. Then we get the other E climate, which is EF, which is polar ice cap. So these are permanently covered with snow and ice. So much of Antarctica, Greenland would be an EF climate. And we can see the location of the EF climates here. So they're in gray, either dark gray or light gray. So some examples. Isachsen, Canada, 79 degrees north. Look at that July temperature. Oh, it gets up to about +4. That's pretty bitter. Looks like there's only about 3 months where temperatures are above 0 for mean monthly temperature. Temperatures as cold as -36 in February. That's a nasty climate. Some summer precipitation, but that precipitation is not from from thunderstorms, it's from mid-latitude cyclones. Here's another example at the tip of Argentina, Ushuaia, Argentina, 55 degrees south. Not as bitter of a climate, surrounded by the Southern Ocean, moderates it, but it doesn't get above 10 and seems to stay above 0 for the months. Of course, the seasonality is the opposite. And finally, oh, no, not finally, this is second last one, Izmit, Greenland. Summer temperatures get up to, looks like a balmy -10. Temperatures in the winter less than -40. A bit of precipitation here, and probably the location with the coldest temperatures that where there's a good data record is Vostok, Antarctica, 78 degrees south. So we can see the temperatures get no higher than -30, and in the winter months, July and August, we're down to almost -70 for the mean monthly temperature. Now that would be a cold place. And then finally, here are some of the Köppen climate types associated with British Columbia. So we can see you can barely make it out, but in some of the dry valleys, like the Okanagan Valley, we do get BSK climates. There is some CS Mediterranean located around Victoria and Vancouver, considered areas around Vancouver Mediterranean. A lot of CFB, CFC along the southern coast and Vancouver Island. And then in the interior and up north, we're getting D-type climates and even some ET tundra climates, and those would probably be associated with highland areas. So that ends our discussion on the Köppen climate classification system.